Control Logix system is a new standard in control system architecture. The high-performance modular platform makes it well-suited for sequential, motion control, process control, and drive control applications. This platform allows the mixing of I/O controllers and networks without restriction. The RS Logix 5000 programming environment is used for the Control Logix platform. It can connect to the NetLinks Open Networks architecture and offers a wide range of specialty I/O modules, as well as analog and discrete modules. The Control Logix platform is easily integrated into existing plant floor communication systems. Included are communications modules for remote I/O, DeviceNet, Ethernet IP, and Data Highway Plus. Features of the Control Logix system. 1. Multitasking, multidiscipline controllers. 2. Multi-language programming. 3. Integrated motion control. 4. Producer-consumer network model. 5. Removal and insertion under power. 6. Flash upgrades. 7. Coordinated system time. 8. Communications gateway. Multitasking multidiscipline. This feature allows the controller to handle up to 32 tasks, 1 continuous and up to 31 periodic or simply 32 periodic. A task provides priority and scheduling information for a set of 1 or more programs that are executed based on a specific set of criteria. These tasks operate interrupts so that the controller will suspend execution of the current task to perform the task being called. Each individual task can schedule up to 32 programs. Each one of these programs can have their own data and logic. This will allow machine processes to be controlled independently, all within the same controller. With the release of version 11 of RS Logix 5000, the Control Logix system became capable of being programmed using 4 languages. They are traditional ladder logic programming, sequential function chart programming, structured text programming, and function block diagram programming. This tutorial will cover only ladder logic programming. The producer-consumer network model is used by the Control Logix system. In this type of network, the producer places a connection ID at the beginning of the data packet. The packet or message is then multicast, and each module screens the ID to determine if it needs the data. If it does, then that module becomes the consumer. This allows the programmer to have 1 or many modules to listen for and consume data with its specific connection ID, while discarding or ignoring all others. Use of this type of networking model allows individual modules to produce data without having been pulled by a controller first. Data will be multicast based on either a time interval or a change of state. Embedded into the Control Logix system are motion control commands. These commands allow the system to control anything from simple point-to-point moves to very complex gearing moves. Removal and insertion of modules while under power is possible without disrupting the operation of any other module in the system. This feature makes it possible to replace faulty or failed modules while the system is running. This will minimize downtime and process interruption. The modules for Control Logix systems, including controllers, communications, and motion modules, are flash upgradable. This feature enables the user to perform flash memory upgrades to the firmware version of any module. Coordinated System Time, or CST, provides a means for the Control Logix system to offer a relative time signature for all events. The CST is available for all modules. The Control Logix system can also function as a communications gateway. It can contain the modules needed to communicate with other networks, such as remote I/O, Ethernet IP, Data Highway Plus, and ControlNet. This feature allows communications with existing networks so that messages may be sent to and from the other networks. The Control Logix system uses the RS Logix 5000 programming environment. This programming software is a vital part of the system. All programming and configuration of Control Logix controllers, communication modules, specialty modules, and I/O modules is done using RS Logix 5000. Communications between RS Logix 5000 and the Control Logix hardware requires the use of RS Links software. Establishing the communications link requires that a driver is set up in RS Links. When RS Links is opened, the screen shown here will be displayed. The icon bar is available to provide shortcuts to some of the most commonly used functions. Become familiar with these shortcuts to save time when working with RS Links. Click the drop-down arrow to choose the appropriate driver. Check your documentation to determine which methods of communications you are using. This demonstration will use the RS-232DF1 devices. Once RS-Who is opened, click the plus sign next to the AB-DF1 segment of the network. Once communications is established, locate the RS Logix 5000 icon. Clicking it will open the Program Editor Configuration application. We will now discuss the various components of RS Logix 5000. Click the icon shown below. Configuration of the I/O modules of a system is essential. We will now cover the procedures for the basic configuration of these modules. A project file is created for a Control Logix controller that contains the configuration and programming information. The project itself consists of three major components. They are task, programs, and routines. The Control Logix controllers use tags to identify the memory location in the controller where the data is stored. There are no predefined data tables, such as those found in an SLC. There are, however, predefined data types. It is possible to group data by defining an array. An array is a grouping of tags of a similar data type. It is also possible to create tags before the logic is entered. It is also possible to use a question mark instead of a tag name and assign the tags later. There are three types of tags: base, alias, and consumed tags. A base tag defines the memory location where the data element is stored. An alias tag will reference a memory location that has been defined by another tag. The Control Logix controller contains a group of predefined data types. The two predefined types are basic types, which follow the IEC 1131-3 data definitions, and the structured types, which are created for a predefined function using the basic types. Memory allocation for user-defined structures depends on the data type of the member within the instruction. The user-defined structure memory allocation. Example 1, shown above, shows the memory allocations for a user-defined instruction. The user-defined structure memory allocation example 2 shows the memory allocations for a user-defined structure where one member is the previous user-defined structure. The member is taken from example 1, where data allocations 3, 4, and 5 are from the previous structure. The members within a structure are addressed by using the tag name and a period, followed by the member name. If the structure is within another structure, the tag name of the highest level is followed by the substructure tag name, followed by the member name. Arrays are used for grouping sets of data of the same data type in a contiguous block of controller memory. A single tag within the array is one element of the array. The element may be a basic type or a structure. The elements begin with 0 and extend to the number of elements -1. An array can have up to 3 dimensions, unless it is a member of a structure. If it is a member of a structure, it can have only 1 dimension. Arrays support user-defined data types and any predefined data types except axis, message, or motion group. The graphic of the single-dimension array shown on this screen illustrates the memory layout of an array with the tag name of temperature data. The data type is DENT7, which indicates an array consisting of 7 elements. The elements are numbered 0 through 6. The two-dimensional array in the example illustrates the memory layout of an array with the tag name of product data. The data type is DENT72. The first column of the array may contain data for a part number, while the second column of the array may contain data for a part color. This array contains 14 elements. The three-dimensional array shown on this screen illustrates the memory layout of an array with the tag name of ingredient data. The data type is DENT723. In this example, the first dimension may represent a product number. The second dimension may represent the amount of a particular ingredient for that product. And the third dimension may represent the quantity of that product that is to be made. There are a total of 42 elements in this array. In an array, there are element addresses and bit addresses. Each type may be numeric, fixed, or variable. The examples shown here have numeric addressing within the brackets. One or more numbers were placed inside the brackets. This makes the addresses fixed. To make an address a variable address, the following format is used: array, name, tag, or expression. An example of variable element addresses may be temperature data degrees Fahrenheit, ingredient data quantity -3. You will note that the example above includes a mathematical operator, the minus sign. Mathematical operators may be used in an array to specify an array element. The mathematical operators used are as follows: add, subtract, multiply, divide, and, from BCD to integer, complement, or, from integer to BCD, square root, exclusive or. When using a variable address in an array, the address must always fall within the boundaries of the array. If the array's dimensions are exceeded, a major fault will be generated. Numeric bit addressing within an array uses the following format. Example: array name element number .bit, temperature data 2.5. Variable bit addressing within an array uses the format shown below. Example: array name element number .tag or expression, temperature data degrees Fahrenheit .index -3.